Okay, guys, let's review how to factor quadratics. So we are going to talk about factoring out the greatest common factor and the other method of factoring by grouping. So when we first look at a quadratic or any polynomial and we are factoring, we always ask if there's a GCF, a greatest common factor, and we have to factor this out first. Also, if the leading coefficient is negative, like we have in this first example, we must factor out the negative. So let's ask ourselves, what can divide into all three terms? What's the largest factor of all three terms? And I can see that -4 can divide into each of those. So -4 is the GCF. Let's change this so we can see it. So -4 is one factor. So we're going to divide a -4 from each of these terms, and that will give us our remaining factor. So we have 3x squared minus 4x plus 6. So -4 is one factor, and this quadratic is the other factor. We could try to go on to see if this can factor more, but for now, I'm just showing you how you factor out the greatest common factor. Now let's look at our next example, and this method is factoring by grouping. So we are trying to create two terms that still give us the -11x. So we're trying to break this linear term into two terms so we can have four terms so we can do our grouping. So we're going to ultimately be factoring x squared, and we have to factor +28. There are several combinations, or really infinite combinations, that could give you -11x. So let's use our graphic organizer, and notice that we do have our A is 1, and so we say 1 times C, so 28 is our product, and -11, the coefficient of our linear term, is our sum. So what two factors of 28 add to give us -11? So we know that 7 times 4 is 28, but that would give us +11. So these need to be negatives. -7 times -4 is +28, and it also gives us a sum of -11. So we can break apart 11x into -7x and -4x plus 28. Now, if you have learned the quick trick, when A equals 1, I advise you to go ahead and use that. And so I'm going to go ahead and show you that quick trick instead of doing all the grouping. And so ultimately we have x and x. So that came from factoring x squared. So you factor your quadratic, x times x is x squared. And we decided that we're going to factor 28 using -7 and -4. So these are our two factors, our two binomial factors that give us this quadratic trinomial. But again, this only works when our A is 1. Whatever your two side numbers, that is going to be your constants of your binomials. Our third example is we are going to ask, is there a GCF? And there is, so I can factor out A2. So once we factor out A2, we have 2x squared plus 5x plus 3. Now we're going to factor, so we have one factor of 2, and then we have this trinomial, but we are going to factor it, and we are going to use our graphic organizer. 2 times 3, A times C is 6, and our linear term is 5. So what two factors of 6 add up to give us 5? So that's going to be 3 times 2 is 6, and 3 plus 2 is 5. So that checks out. So we're going to rewrite our middle term. Instead of 5x, we're going to break that apart into 3x plus 2x, and then plus our 3. Now we are going to do our grouping. So I'm going to go ahead and put brackets around this, and then we're going to group the first two terms and the last two terms. So we have, in this binomial, we had to factor out the GCF. So here's the original GCF, don't forget that. And then from this binomial, I can divide out an x. So I'm going to bring out an x. And then we're left with 2x plus 3. My operator is plus, and the GCF of 2x plus 3 is 1. Now, usually 1 doesn't help when you're factoring out, but it does in this case. And when I factor out the 1, I have the 2x plus 3. And remember, guys, when these two binomials match up, you know that you're on the right track. So we have 2, the GCF, and then our first binomial is x plus 1. That comes from the two GCFs here. And then that binomial that was the same, that is your second binomial factor. So we have 2 times x plus 1 times 2x plus 3. So let's practice a few more. But before we get there, let's look at when we factor some special quadratics, such as a perfect square trinomial and the difference of two squares. So here we have a perfect square trinomial because we have a perfect quadratic term and we have a perfect constant term. And if we take the roots of our quadratic and our constant, we get 9x. And if the middle term is that doubled, then this is a perfect square trinomial. And when you can recognize that, this is easy to factor. So let's go through the 3 steps of factoring a perfect square trinomial. Each term plays a part in factoring. I'm going to go ahead and set up. You can set it up like this, or you can do a single parenthesis squared. These are going to be the same. So you take the root of the quadratic, which is x. You take the sign of the linear, which is plus, and then you take the root of the constant, which is 9. Or we could write it as x plus 9 quantity squared. Let's look at our second example of a perfect square trinomial. 1x squared is a perfect square. 225 is a perfect square. The root of 225 is 15. 15 times the root of x squared is x. That's 15x. Doubled is 30x. And yes, it's fine that this is subtract, but our constant would never be a negative right here. Okay, so set up to factor. So I take the root of the quadratic. I take the sign of the linear. And I take the root of the constant. The next special case is the difference of two squares. The difference of two squares is when you have a quadratic and a constant only. There is no linear term. There's no x to the first term. And it is a subtraction. It is the difference of two perfect squares. So we're going to set it up, and we are going to have one binomial as plus and one as subtract. And we take the square root of x squared, and you take the square root of 144. And what makes the linear terms go away is that you have a plus 12 and a minus 12. Here we have a difference of two squares. One's going to be plus, one's going to be minus. The root of x squared, break it apart, and then the root of 400. So those are your two special cases. And if you can recognize these, then it only takes a few seconds to factor. If you don't recognize them, factoring by grouping using your graphic organizer with A times C on the top and B on the bottom will still lead you to the right answer. So let's factor these. These are just a whole bunch of different quadratics, and some of them are going to be polynomials. And let's factor. So our first one here, we have x squared minus 8x. Do we have a GCF? That's what we always ask first. The answer is yes. They both have an x. So that leaves me with x minus 8. And that is all you can do. You are done. So our two factors are x and x minus 8. Number 2, I want to see if negative 3 can divide into all of these. So I know it can divide into negative 6. Now let's see if 3 can go into 105. And I do believe it does. Yes. So it goes in there 35 times. So I'm going to factor out a negative 3 for the GCF. and then we are going to be left with, and this is going to be a negative 35. Okay, so now let's see if this trinomial can factor. It may not can, and we may be done right here. So we have 1 times negative 35. If you hear my doggies, just ignore that. And so we know that 7 and 5 would give us 35, and we need one of these to be negative, and it needs to be the smaller one because we have a positive. So now we can do that quick trick. So we have x plus 7 and x minus 5. We factored the x squared into x, and we factored the constant into 7 and negative 5, and we're done. Okay, there is no GCF because our A is 1. Let's see what we have here. 1 times negative 9 goes on top. Negative 8 is on the bottom. We're thinking of what times what gives us negative 9 and adds up to negative 8. Well, that is going to be negative 9 times 1. Okay, so we can just simply say x minus 9 and x plus 1, or vice versa. Here, I recognize this is a perfect square trinomial because this is a perfect square. 16 is a perfect square. Now let's check the middle term. This has to check out. The square root of 16 is 4 times the x here, that's 4x, and doubled is 8x. So I simply can either write it doubled or raise it to a power of 2. So you take the root of the first term, you take the sine of the linear term, and you take the root of the constant. Or you can just have x minus 4 quantity squared. Now, if you did not recognize this, we would simply use the graphic organizer, 1 times 16 and negative 8. And you could clearly see that negative 4 times negative 4 gives you that 16 and adds to the negative 8. So the grouping works all the time. Okay, let's do these 4 more. This is a perfect square, this is a difference of 2 squares, dots, difference of 2 squares. So we know we're going to have one that has a plus and one has a minus. So we factor x squared and we factor 16, and here we go. Number 6, this is just a polynomial. It's already 4 terms. So we just go straight to the grouping part, and we are going to factor out the GCF. So this one is going to be 2x squared. That leaves us with 4x minus 7 plus, here we can factor out a 7, and we have 4x minus 7, so we know we're on the right track. Our first binomial factor is 2x squared plus 7 times the 4x minus 7. On number 7, there is a GCF. We have to factor out this negative 1, and then that leaves us with x squared minus 12x plus 20. So now we have 1 times 20, negative 12. So you're thinking the factors of 20, 2 and 10, 4 and 5, and 2 and 10 is what it's going to be, but they need to be negative. And we have negative, and then we're going to have x minus 2 times x minus 10. And there's no GCF. Our graphic organizer, 1 times negative 54, and then we have 3. So 54, 6, and 9, I believe, and the 6 needs to be negative. Our A is 1, so we can say x minus 6 and x plus 9. And again, at any time, you could redistribute your factors to see if you do get back your original. So you can always check your work. And I hope this helps.